On our last page of notes, we're going to look at how to solve for time on a particular financial problem. So let's dive into our example. How long will it take for an investment to double if its value earns 5% compounded continuously? Remember, if it says double, on the last example we looked at a fast way to do this, and we'll look at it the long way again, but you're welcome to take the shortcut. 5% compounded continuously, which automatically means we need to be thinking about E, or in other words, our PERT formula. So if we're not sure what our shortcut is going to be when it asks us to double, we can again assume that we want to invest $10, and how much should we have at the end? Of course, we want $20. So when we substitute in, our ending amount is $20, our beginning amount is $10, E, of course, is a number in our calculator. We know our rate, 0.05, and time is what we're asked to find. So when I look at this problem, although the numbers look kind of messy, I can see that I have an exponential problem because my variable's in the exponent. So to solve my exponential, I'm going to isolate the exponential piece first by dividing by 2. And sure enough, there's that 2 for our doubling that we were expecting to find. Once I get to this point in the problem, all I'm going to need to do is switch to my logarithmic form. So when I switch to my logarithmic form, I end up with log base E of 2 equals 0.05t. Now, I understand that log base E, when I type that in my calculator, is effectively natural log 0.05t. So you can rewrite it at this point or not, but I do know that I eventually have to divide by that 0.05. So my time equals the natural log of 2 divided by 0.05. I can approximate that by typing it in my calculator and get 13.86 years. The last scenario that we're going to look at today is the idea of uninhibited growth. On an uninhibited growth problem, the equation will be provided for you, and you're simply asked to analyze the equation. This is our standard form for our uninhibited growth, so we can just jump into our example where the equation has been provided. The uninhibited growth problems will encounter all of the scenarios that we saw in our financial models. If it asks us to determine the initial amount of the bacteria, what we can see from up above is N of T is how many grams of the bacteria we have, and T is in days. So if I want to know how many grams I had in the beginning, I can just see it by inspection and see that my answer would be 100, or I can understand that I'm trying to find N of 0. So if I do 100 times E to the 0.045 times 0, my exponent now becomes 0, and anything to the 0 power is 1. So that makes sense that my answer is 100 grams. So of course I could have done this problem by inspection, but I could write it out as well. My growth rate, we understand, is simply going to be taken from that exponent. So I have this 0.045. I can convert that to a nice percent by moving my decimal point. In other words, 4.5%. My population after 5 days is really no different than what it was asked in the beginning, was my population at time 0, so I'm looking for N of 5. 100 E 0.045 times 5 days. And again, I'm just typing this in my calculator. We've been here before, done these types of things already today. Decimal approximation, 125.23 grams. Make sure to label your answer on all of these word problems. Now I end up with this question of how long. So when we see this how long, we should be thinking about what we did on the last example. So I'm looking for time, so I have 140, because I know this is my final amount, is 100 e to the 0.045 t. I can divide by my 100 in the same way up above I divided by my 10. So I get 140 over 100 equals e to the 0.045 t. Switch to my logarithmic form, and I can also reduce this fraction right here. Remember, you don't need a calculator. Those zeros would cancel. 14 is divisible by 2. 10 is divisible by 2. So I can easily get that simple decimal. So I get log base e of 7/5 equals 0.045 t. My final answer then, t equals the natural log of 7/5 divided by 0.045. Just switching. Again, decimal approximation, 7.5 days. The last one is, what is my doubling time? So again, I'm calculating time, but I want to think about what should my final answer look like. So I know that I started with 100 grams, so that means that I want to end with 200 grams. And now we're back to the exact same problem that we've done before. 2e to the 0.045 t, I simply divided by the 100. Switch to log. Log base e of 2 equals 0.045 t. All I'm left to do is divide by my decimal. So my time is natural log of 2 divided by 0.045, decimal approximation, 15.4 days. I can also see that this answer makes sense because when I think about 15.4 days compared to the 7.5 days, and then I think about how many grams I had, that makes sense when I think about 200 versus the 140. So it's good to stop and think about how reasonable your answer is.